Hey y'all, welcome back. On tonight's homework, we're going to be using the second derivative test, the first derivative test, and really just overall do a little graph analysis. We want to make sure that we understand the connections between the graphs of f and f prime and f double prime, and whether or not these functions are positive or negative, and how that relates back to the graph. So number one says, what are all values of x for which the function defined is increasing? So we want to know, and this is really going to be our justification, we want to know when is the first derivative positive. Okay, so our justification is that f prime is positive. So and you can get the justification right away as long as you know what it's asking for. So let's go ahead and find f prime. We're going to do that by using the power rule across every term here. So 3x squared plus 6x minus 9. We will find our critical values to create our sign chart for f prime by setting this equation equal to 0. I can factor out a 3 and factor the remaining quadratic. So that would be, x plus 3 times x minus 1. So we get two critical values, one at x equals negative 3 and one at x equals 1. So with this information, I'm going to construct a sign chart for f prime, and I'm going to label my two critical values here. These are places where we have a potential relative extreme. And so now we're going to check on each interval here whether or not f prime is positive or negative. So I'm going to be plugging in representatives from each interval into, I'm going to use the factored form here. Now I'm going to ignore the 3 because multiplying anything by 3 is not going to change the sign. So I'm just going to really be focusing on the two factors, x plus 3 and x minus 1. So if I plug in a number like negative 5, I'm going to get a negative number times a negative number is positive. If I plug in 0 for that middle interval, I'm going to get 3 times negative 1, and that is negative. And finally, in that last interval, I could plug in something like 10, which will result in a positive times a positive, so that is positive. So there's going to be two intervals where the function's increasing. Okay, so f is increasing whenever the derivative of f is positive. So if it's negative, f would be decreasing. Okay, so the slope is positive both where x is less than negative 3 and where x is greater than 1. So our answer is C, and the reason we know it's C is because that's where the derivative is positive. Number 2, we have the graph of f prime. Okay, so we really want to make sure that we know which graph we're looking at here. It says, which of the following statements must be true? Well, the first one says f has a relative minimum at x equals negative 3. So there's two ways to check this. Okay, if we use the first derivative test, what we're going to look for is a sign change of f prime. So f prime goes from, for local minimum, negative to positive. Right? If you have a graph that's doing something like this, you can see the slope is changing from negative to positive. So that's how you would check this with the first derivative test. If you want to use the second derivative test, which is totally fine, what we would need to know is that f double prime, we want a concave up scenario, so f double prime would need to be positive. So we can basically check one of two things. We can see, and maybe we'll just check both, just so you can really see that you could use either one of these. This is the first derivative test, and over here, this is the second derivative test. And so you have your choice on which one you want to do here. But let's take a look and see what's going on at negative 3. So negative 3 is right here. We can see that we are, in fact, changing from a negative value. F prime's going from negative to positive. Right? And we can also see that f double prime is positive, right? The slope of f prime, and that's what f double prime is. It's the slope of f prime, we can see overall right here that the slope is positive. So whether you want to use the first derivative test or the second derivative test doesn't matter. Whatever one is easier for you to comprehend will work. But either way, this is going to be a true statement. So one has got to be true. So we can eliminate B and C here. Let's test out number 2. The graph of f has a point of inflection at x equals -2. So x equals -2, I'm looking over here. It's right about here. Okay, so here's -2. Okay, so for a point of inflection, what we need is a sign change on f double prime. That's where the point of inflection is. It's where f double prime changes sign. So another way to interpret that is that the slope of f prime changes sign. So another way to think about it is a sign change on the slope of f prime. That's what f double prime is anyway. So we can see that the slope is right before -2 is positive, but then right after -2 is still positive. So we do not have a sign change on f prime here. So 2 is not going to be correct. So it's definitely not going to be D. And so now we need to check the last one. Is it concave down between 0 and 4? So in order for it to be concave down, what must be true is that the second derivative must be negative. Okay? Another way of thinking about it is that the slope of f prime must be negative. So looking at this, we have the graph of f prime, so it's probably going to be easier to just think about it as the slope of f prime. And so between 0 and 4, so that's between 0 and 4, is the slope negative the whole way? The slope of f prime? Sure is. That f prime's decreasing the whole interval. So that means that 3 is a true statement, and our answer is E. Number 3. Number 3 says if g is a differentiable function such that g is always negative, put a little symbol here as a little reminder, for all values x, and they give us a formula for f prime, which of the following is true, and all these answer choices are talking about relative max and mins. So relative max will occur if the slope changes from being positive to negative, and a local minimum will occur when the slope, or f prime, changes from negative to positive. So if we look at f prime, we want to know, what's happening here. Let's create a little sign chart. Do we need a sign chart here? What are we doing here? We want to see, what are our critical values? So let's see, we got x squared minus x minus 12 times g of x. We want to set that equal to 0. So we're going to say, we're going to factor this first one and say x minus 4 times x plus 3 times g is 0. So we're going to get, we're only going to get 2 critical values. We're going to get 1 at 4, and we're going to get 1 at -3. G of x, it says it's always negative, so it's never going to be 0. So that's not going to produce a critical value. So I'm going to create a little number line chart here, put -3 and 4, and I'm looking for those sign changes. So if I input a number like -10, I'm going to get a negative times a negative times another negative is going to be negative. Then between -3 and 4, I can pick a number like 0, which would result in a negative times a positive times a negative, which would be positive. Remember, g of x is always negative. Then if I plug in a number like 10, I'd have a positive times a negative is negative. Okay, so at -3, we have a slope that's going from, because remember, this is f prime, going from negative to positive. So we have a local minimum at -3. And then at 4, our slope is changing from positive to negative. So we've got a local max. So let's look at our answer choices here. Yeah, we got a relative minimum at -3. Okay, so it looks like A and B are looking good. And a relative max at 4, so our answer is B. Number 4 says, given the function defined by this cubic, find all values of x for which the graph is concave up. So we got to know what it means to be concave up. Your function will be concave up if the second derivative, and this is really your justification, is positive. So what we're going to do is we're going to find that second derivative, create a sign chart, and find the intervals where f double prime is positive. So let's find f prime first. Need that to find f double prime. Okay, now we've got f prime. So now let's do f double prime. We're just using the power rule here. 60x cubed minus 120x. Okay, so we want to set that equal to 0 to find our subcritical values. And so I can factor out 60x as a GCF, which would leave me with x squared minus 2. Yeah, I guess so. Is that right? Yeah. So I'm going to get 3 subcritical values, either x equals 0 or x equals plus or minus root 2. Now I'm going to create a number line chart here with 0, with negative root 2, and positive root 2. And I'm going to start inputting values into my second derivative. And I'm going to go with this one right here. So if I plug in a number like negative 10, that'll be a negative times a positive, which is negative. If I plug in negative 1 for the second interval, I'm going to have a negative times a negative is positive. Then if I plug in 1, I have a positive times a negative, which is negative. And finally, I've got in the last interval, if I plug in something like 100, go really, really extreme, I've got a positive times a positive is positive. Now this number line is for f double prime. So if we're looking for where it's concave up, it's going to be where we have positive values for f double prime. So our answer, we have 2 intervals here. We've got one interval between negative infinity. Oh no, I'm sorry, I'm looking at the wrong one. Between negative root 2 and 0. And then our next interval will be between root 2 and infinity. And our justification is because f double prime is positive. Number 5, where does this function have a relative maximum? Okay, so we can use either the first derivative test or the second derivative test. We haven't really used second derivative test much. Let's try to see if we can use that second derivative test. So my first derivative is going to be 6x squared minus 6x minus 12. You know what? Should we use second derivative? I kind of want to, but at the same time, I don't know that we really need to on this one. So 6 times x, yeah, you know what? I'm just going to use first derivative test on this one, sorry. So x squared minus x minus 2 is going to give me 2 factors of x minus 2 and x plus 1. So my 2 critical values will be at x equals 2 and x equals negative 1. I'm going to make my sign chart here for f prime, negative 1 and 2. I'm looking for a relative maximum, and that's going to occur when f prime goes from being positive to negative. So that's one way to find it. And I was talking about the second derivative case. I'm going to just say, or if you use the second derivative test, you want to check to see if f double prime is negative because it's concave down. So we can check either one of these, and either one's fine. I've already got the first derivative set up here, so I'm going to go ahead and just use the first derivative test, but you could use second derivative test as well. So if I plug in a number like negative 10, I'm going to get a negative times a negative, which is positive. If I plug in 0, I'm going to get a negative times a positive, which is negative. And if I plug in a number like 10, I'll get a positive times a positive, which is positive. So we're looking for where the f prime is going from positive to negative. And we can see that the slope of f here is increasing followed by decreasing, and therefore has a relative maximum here. So we have a relative max at x equals -1 because f prime went from being positive to negative. And it doesn't ask for this, but we can also say that we've got a relative minimum at 2. Number 6. A lot of multiple choice questions here. Okay, number 6 says the graphs of the derivatives. So these are the graphs of the derivatives of 3 different functions. Which of the functions have a relative maximum between a and b? So in order for there to be a relative maximum, we want f prime to go from being positive to negative. So we can see that f prime goes from being positive to negative. Now, keep in mind, we're not talking about the slope here of f prime. We're talking about the value of f prime. So we would have a relative maximum between a and b on this first graph. So for sure, f. Let's take a look at g. Now, g, there's no point, or g prime rather, there's no point where it goes from being positive to negative. We actually only have one subcritical value here. And at that point, it's going from negative to positive. So we would have a relative minimum on f, or on g, but no relative maximum. So this one doesn't have any. So we can say that the answer is definitely not B or D or E. And actually, we don't have to check H because we know F has one, but just to be on the safe side, looking at H, you can see clearly H prime is not going to have a change, a sign change from positive to negative either. So our answer is just going to be A. Number 7. If f double prime is this, what is that, 1, 2, 3, 4 quartic function, then the graph of f has an inflection point where? Well, this one's already factored out for us. So our subcritical values are going to be at 0, -1, and I'm just pulling that from these factors, right? So 0 from the x equals 0, -1, because that would make x plus 1, 0, and then also 2, because that would make x minus 2, 0. So I'm going to create my sign chart here with -1, 0, and 2 on it. If I plug in a number like -10, I'm going to have a negative times a negative times a negative would be negative. Oh, wait, it's squared. Oh, so this thing's squared. This thing's always going to be positive. So I'm going to just ignore that. And actually, a negative times positive will be positive. I'm glad I caught that. So I'm actually going to ignore this squared one, right? Because this thing's always going to be positive. If I plug in a number like -0.5, I'm going to have a negative times a positive. So that's going to be negative. If I plug in 1, that would be positive times a positive would be positive. And if I plug in something like 10, I get another positive times a positive is going to be positive. So we're going to have an inflection point anytime f prime changes sign. So inflection points are when not prime, but double prime changes sign. So we can see there's going to be 2. There's going to be one at -1 and one at 0. So our answer is C. And it looks like we just have one problem left here. So let's go ahead and wrap this up. 8 says let f be a function, and we can see the graph of f prime below. We got 2 semicircles, 2 line segments. All right, let's see what the question's asking. A says state the critical values of f of x. So again, critical values are where f prime either equals 0 or undefined. Okay, we don't really see anywhere on here on the domain of f prime where it's undefined, so we're just going to identify where it's 0. So that's going to be at -5, -3, 1, and 4. Okay, for each one of these, actually, I'm going to rewrite it like this because we need to classify what's going on at each of these numbers, whether they're going to be local max or mins or neither. So in order to be a local maximum, we're going to go from a positive slope to a negative slope. So f prime will go from positive to negative. So we're going to have a max at -3. Okay, and it's a max because f prime went from being positive to negative. If we look at the endpoint at -5, we're not going anything to positive, so this is just going to be neither. At 1, the value of f prime is going from being negative to positive, so we're going to have a local minimum there. So at x equals 1, that's a minimum because f prime went from being negative to positive. And finally, at 4, the value of the f prime is going from positive to negative, just like at -3. So this is going to be another maximum. And for the same reason it was before, f prime is going from being positive to negative. All right, letter B. It says, on what intervals is the graph of f of x increasing? It'll be increasing when f prime is positive. That's really our justification. So our two intervals here, we can see where f prime is positive pretty easily, which is wherever it's above the x-axis. So on this interval and on this interval, so we got two intervals. We're going to write them both between -5 and 3, and also between 1 and 4. Okay, and our justification is because f prime is positive. Our last question of the day is for us to find the intervals for where it's concave up. So in order for f of x to be concave up, and we'll justify using f prime. So it's going to be concave up. So I'm going to kind of write this two different ways. Wherever f double prime is positive, and what that means is that the slope of f prime needs to be positive. I left an f there. I'm going to clean that up a little bit, make it a little easier to read. The slope of f prime is positive. Okay, so when it says justify using f prime, specifically f prime, we're going to use this justification. It would be okay to just say in general that f double prime is positive if it just says justify, but this specifically says you should reference f prime. So we're going to look on this graph, where is the slope positive? Okay, so I'm going to kind of erase all this other stuff and just kind of highlight where the slope is positive. So you can see the slope is positive here. The slope is positive here. And the slope is positive here. So let's write these out. Or I guess another thing you could say is that f prime, I'm going to say or, f prime is increasing. Okay, so our two intervals are going to be from -5 to -4 and from -1 to 2. Okay, because f prime is increasing, or in other words, the slope is positive. And that's it for today. As always, guys, thanks for watching. Y'all have a great night.